In this tutorial, we're going to go over actual modeling in the Revit environment. In the last one, we showed you how to bring in your data from Rhino and SketchUp. DWGs will be the same type. So in this case, I'm going to make a new family, and I'm going to start in the generic modeling environment. The reason why I start in the generic modeling environment is because it gives us access to those tools in button form. Whereas we get more advanced with our modeling capabilities, we'll be able to go into the conceptual mass environment that doesn't have that button functionality. Revit basically says that it knows what you want it to do based on the way you create the geometry. So again, we have these 5 buttons. We have extrusions, blends, revolves, sweeps, sweep blends, and then the 6th is void forms. So then we can do the same set of modeling operations, only they're in a void form. So Revit is kind of like SketchUp in the fact that it's a solid modeling tool. You can do surfaces, which we'll get a little bit into, but it really likes to be a solid object. So we'll make a box and we'll put a hole in it based on the same extrusion tools. So another thing to note is in this generic modeling family, and this is going to be the same for all families, is you're going to see these 2 reference planes. So what that is that's 0, 0. So if I make an object out in the environment over here, right? So I'm starting with my extrusion, right? When I load it into the project or another family, it's going to pull that intersection point that I'm highlighting, and that's going to be the 0, 0. So wherever I load it into, that's where I'm going to load the file. So if this were a cabinet per se, and I wanted it to offset from the wall, which would have been that reference plane here, I would put a parameter or just manually put it so far away from that wall so that it offset embedded into it. Another thing I can do as well, you notice I entered into the extrusion family here. So if I wanted to edit the dimensions of this object, so I want to make this line longer, right? I'm going to select its opposite because it's queuing the endpoints as their dimensions. So I'll say I want it to be 25 feet, right? And if I want to make the other one longer, I'm going to say, click on that dimension, make that 25 feet. Right. And I'm going to type LI for line. And what I want to do is I'm going to use the diagonal here to locate the center point. And I'm typing MV for move, and I'm moving right up into that object. And you notice I'm kind of flying right into this operations. I'm assuming that you have some experience with the modify tools up here in Revit. So again, move that I just did was MV. I can copy an object, so I can copy that off. Excuse me. Select it, type CO for copy, and I can do a reference copy with that. I can also do rotate, so if I want to rotate, I can select this object, type RO for rotate. Now the rotate command, I have this blue button. So the blue button comes at the center or the centroid of that geometry. So whatever if I had some weird piece, it would find the center for me. So what I want to do is if I want to rotate from this bottom edge, I can select up and I can rotate over. Undo that. I can also do it numerically instead of graphically. Type RO. And you'll see I have this ability to copy when I rotate, and I can also tell it an angle that I want to rotate at. So if I were to come in here and move that guy, I can select it and it should copy that over. So those are those basic tools. I also have the ability to offset this, so if I wanted to offset, again, I can adjust how much I'm offsetting in the options bar. I'll offset that piece and I'll offset that piece. So I have a little bit more functionality into this particular object. Another thing I can do is if I finish out this guy, right? So I've gone way longer than I needed to go with my drawing command. I can use the trim command, and again, the trim, it's going to work a little differently than AutoCAD. So I'm going to select what I want to keep, and then it's going to trim away everything that I didn't select. Right, again, I'm in the extrusion family, so I'm going to go ahead and to finish that extrusion mode, I can click the check mark. But prior to doing that, I'm going to go ahead and I'm going to tell it what I want my extrusion distance to be. So a few other things in the properties bar, and this is going to be the same for all the objects that we create today. I'm going to tell it I want it to be 100 feet tall, and I'm going to put a material on it here. I can do it manually. Later on we'll learn how to do it parametrically. Right, I'm just going to give it that default wall so we have a color on it. I'm going to check mark, and we have our object. Now you'll notice when I select it I have these arrows, so those are handles to control how wide I want the object or how thick I want the object. So even after I've made the pieces, I can still come in and I can change how wide or how thick those are, and in this case I selected how far away I wanted it. If I wanted to numerically change how thick or how wide that piece is, I have to come in and actually edit that original extrusion, and I'll come in and change that to be 25 feet. And so I'll check mark and I'll be done with it. I'll go to my 3D view to make sure that my piece is as tall as I want. Type ZF for zoom full. And there we go. And again, I get the ability then in the height to adjust that. Alright, but you'll notice that I don't have much. This is just a single object. In the massing environment, we'll have more control over how to edit this piece, and you treat it like as if it were a sculptured piece. Generic modeling family is really confining and has a lot to do with making individual pieces and components, kind of. So the next thing we'll go over is doing the blend. So I'll delete that off. I'll come back to the floor plan. Now the blend tool, so I come here and we'll highlight and wait for the tooltip to come by. So the solid blend is going to basically give you a bottom piece and a top piece, or you can do it rotated, so you're drawing an elevation. It would be a left piece and a right piece. And sometimes you might want to just go ahead and make that as a sweet blend, which you'll learn a little bit later. So what that piece does here is I can basically make a bottom part and then a top part and then adjust those dynamically. So I immediately enter into the base command, and it's going to let you to do from the properties window. You can either adjust it graphically using the handles as we did it in the last case, or I can come in and do this ahead of time and adjust how far up it goes. So I'll select the rectangle tool and I'll just do a simple base. I'll come into my polygon tool, and I'm going to tell it I want 3 sides, so we'll make this one a triangle. Right, so what it's going to do is, the triangle we're going to want to put on the top piece itself. I got a little ahead of myself, sorry guys. So when I'm done with that, I have my bottom piece. I'm going to come to this mode and say edit top. So the edit top is where I'm going to load into that third triangular piece. Alright, and this is going to look a little top heavy, but for demonstration purposes I think it works pretty well. And I'll just check mark, and you'll see it creates now. Now it doesn't have the full form. That's because you got to remember in the floor plan view we're actually cutting through that. And if you want to play with how to adjust those, how it's cutting through the object, you can come into the reference levels, view properties right here, and then adjust that through its view range. The view range is here. And we'll just cancel out of that so you know where that's at. We'll come to the 3D view and you'll see I have my object. Now I also can put material on it so I can actually see that in the view. So we'll switch that over so I'm actually looking at it, and again my display options are here. So now I actually have a great view. I can see what that object is. If I want to come in and I want to edit that at another time, I can come in and either edit the base. Well, let's say I want to make the base bigger. In this case I made the base, too small. So I'll pull that out and I can graphically adjust how wide that is. Right, and let's say I'm done with that. Right, so now it looks a little bulky at the bottom and a little thin at the top. What I can do is select my piece, and I can come over to my second end and make it 125 feet. And then we have something that looks more like a tower that could be built. Okay, so the next one we're going to go over is the revolve command. Now the revolve command is going to be looking for a boundary line, which is also the cross section that you see in pink on this graphic. The next one is going to be the axis line, which is what it actually revolves around, which is what you see in this particular set. So I've already moved to the elevation front view, and I'm going to start with my boundary line, and let's just go ahead and make a curved piece of steel. So we'll draw the cross-sectional area or the cross-section of a particular C section. Right, so we'll just draw a generic C section here. Right, and that might be my piece. Might be accurate, might not be. For demonstration purposes, it works pretty good. And I'll draw that in. Oop, I went too far with it. Just want to do that. And you know, I'm going to go ahead and I'm going to move this MV. I'm going to make it really far out there. And we're going to use our center line of our reference planes to actually make a curved piece of geometry, or curved extrusion for that matter. So in Rhino, this would be like your sweep along a path kind of thing if you're doing a revolve, or you can do the revolve the same way. So what I'll do now is I'll do my axis line, and I'll pick my axis line based on my reference plane. I could also draw it in, but I think knowing how to do the reference plane by picking something helps a lot with understanding how we set up geometry later on when we do parameters. Alright, so I'm going to go ahead and I'm going to go check, and it's going to make my circular piece. Now the one thing we need to do is let's say I didn't want it to be a full 360. So Revit by default makes it a full 360 degrees. Now I have yet to see somebody that can make a completely solid 360 degree piece of steel. Usually it's going to be two pieces that get welded together. So in this case, I'll select my object geometry, and I have this start angle and I have an end angle. So the same thing that we did in the extrusions, I can also come in and say I want to make it only 180 degrees. So that gives me my arched C angle piece. And that's basically the tools in the revolve command. Again, if I want to edit the profile, I can come in and say, you know what, my piece needs to be way bigger. It's definitely not going to hold whatever it was meant to hold on there. Excuse me. Select my piece. I'll drag that up. So then if I want to make it bigger, I can check mark and it'll make my C section bigger. Or if I say, you know what, I can actually get it to come out, and let's say I want to make it 270 degrees, I can change the amount that it curves. So let's say I had this same C section, and I wanted to make it so it was, you know, more elliptical of a curve, or it was along a different path. So it was something that was curved in two directions, right? Then I would come in and use one of the tools for a sweep command. So I would do a sweep with it. So the next thing we'll do is with the sweep blend, if it's something that I need to do in double curvature or it's just an irregular path, I'll do it as a sweep, right? So in the sweep, I can either pick the path or I can actually sketch that path. So if I go ahead and I sketch that path, I'm going to come in and I'm going to do a spline tool. So I'm going to make something that's relatively curved in both directions, right? And then I'm going to need to actually get something perpendicular to that path. So with the way Revit's set up, it's orthogonal views, so I have no way of actually getting to that perpendicular point. So new to the Revit series is this actual work plane viewer, and the work plane viewer then allows me to get directly onto where that profile is. So in this case, I'm going to finish out of my path, and I'm going to come over and I'm going to edit my profile, and it's going to ask me, do I want to open up the work plane viewer? I'm going to say yes, I want to open that. And now I'm perpendicular to that path, and I'm allowed to make my actual cross-section geometry. In this case, I'm going to make a C-section. Alright, and I'm going to check mark out of that. And now I'm left in the command in the work plane viewer. I'll close out of that. And if I come over to my path, you'll notice that I laid it off of the side of that path, so I can also lay it on the path like we did before, or I can take advantage of saying that this particular piece is now centered off of the path. So in the instance of maybe I had this laying up against a wall and I'm going to have fittings that come off to hang this C-section, I can actually do that ahead of time before I have my fitting pieces in. So I'll come over to my 3D view. I'll spin around here, and then I'll finish out of my command. You'll notice that I have my C-section along that path that I did. Right, so let's say we've even gotten more fancy with this. You know, we can edit it, of course. I want a bigger C-section that tapers down into a smaller C-section. So what I can do is then come over and I'm going to enter in the sweep blend form. So I'll delete this off. Right, and I'll go to the Home tab, and then I'll do a sweep blend. So it works the same way as the regular sweep does, but instead I'm going to come to my reference level, reference plane, ZF for zoom full. So I get to the center point, and I'm going to sketch my path, selecting the spline tool. Right, and you'll notice now, because I have a start and an end point, the sweep blend is going to say what do you want it to look like at the end, and what do you want it to look like at the start. And that's based upon what they call is a profile 1 and a profile 2. So the first one is I'll select profile 1, and I'm going to open that viewer. Right. Select profile 1, edit the profile, and then go to the work plane viewer. And what you're going to do is then draw in what you want. So in this particular case, I think I'm gonna abandon the C section, and we're gonna make a canopy here. So that canopy, I'm gonna make an elliptical canopy that tapers into a circular canopy. So we'll make it let's make it pretty big, so it's something more realistic, like 22 feet. Make it 12 feet high. Right, and I need to trim that, so I don't want to come back later and worry about the bottom part. So another part of the trim is with circular trims or elliptical trims is I can select that line, select the other line, and then select the top piece and select the other side of the line. It'll actually turn it into a hemispherical portion. And in this case, I'll check mark out of the profile 1, and then I will come in and do profile 2 and edit that. And since I already had my work plane viewer open, it automatically defaults me to that work plane view. So in this case, I will select the circle and drag that up and make the circle now somewhat to the size of what the other one was, and it's at 10 feet. Let's say I want the circle actually to taper down to 6 feet for a radius. I'll draw in my line, drag that over, type TR for trim, select the piece I want to keep, and then select the top left and bottom piece. Now I have a hemispherical cut on that circle. I'll go ahead and check mark out of it. And now it's going to say, if I look at this, it's going to look kind of funny. It's going to look like a kind of like a tuba horn at this point. So I would come in into my sketch path and select that, and then I would actually modify that at this point if I've seen it, instead of looking at the geometry. And I can drag that out and make that bigger. And with the control points, I can drag in and drag out. Pull that back more. And then I can say, yes, I'm happy with that path. I pull back and look at what it's like, and I check mark out of the complete. Now you'll notice I get this cannot create sweep blend. So I'm going to cancel out of that, and why you can't create it is going to be this arc that's occurring on the piece itself. What I need to do is I need to edit my path now so that it actually does not have such a bend in it. So if we were to actually pull that control point in, pull that control point in, because it's a more gentle sweep, it'll actually then allow me to make that sweep blend. You'll notice, yes, it does. Right, and I can come to my 3D view. And then I have my piece. Right. So let's say we want to actually put a hole through the top of this object. What I can do is I can come into the reference plane view, right, and I'm going to go and make a void form. And let's say we wanted to make a square through the actual piece itself. Check mark through that. When I come into my 3D view and look at it, it should now cut through that object's geometry, right? And I can change the way that piece cuts. I can change the side of it through the handles, and so on and so forth. So what that does is it allows me to do a variety of solid operations as well, just as we did the some void operations, just as we did the solid operations, each one cutting and adding to the piece we're trying to actually build. Now this is great for specific components and really kind of precise geometry, is if what I would call it. Now to really sculpt out forms or masses of buildings, you're going to use the conceptual mass environment, which we loaded the other massings into. So what I'll do is I'll load in a new mass file, do conceptual mass, and I'm going to do a mass RFT and open that. right? So you'll know from the last tutorial that this massing environment is 2 reference planes at the centers with 1 level, just like the generic modeling environment, but I have the gradient background, so I know. The one key thing to note inside this conceptual mass environment is that I can no longer have access to those buttons. I have one single button for all my modeling operations. So if I wanted to make an extrusion, I make a rectangle, and then I have my box. If I wanted to make a revolve, let's undo what we just did here. If I wanted to do a revolve command, I can set my work plane to that piece. And I'll show my work plane so I know that I'm on that. Then I'll open my viewer so I know I'm up and down. I'll draw in my revolve axis, right, and then I'll draw in my actual cross section. Right, so let's say that was my cross section, a series of circular floating planes. What I can do then is select this object, create form. It's going to say unable to create form element. What I could also do then again is select one by one, create it. It's going to make a circular piece. Excuse me, let's come back. So I'm in my work plane viewer. What I'll do is I'll actually make my revolve axis first. I'll come in and make my revolved piece. So in this case I want to have a, you know, that same kind of circular staircase happening. Right, and I'll close off that geometry, right, and I'll just select everything within that object set, and I'll create form. So Revit automatically knows that I want to make a revolve without actually doing the revolve command. So in some ways this is really powerful in the fact that I don't have to tell Revit by a button click what I want to do. I can just go ahead and do it. Another thing too is since it's so loose, it allows me to start doing things more like as if I were sculpting in the computer versus you know, being so precise as we were in the generic modeling environment, right? So I can make just a small slice out of it, 180 degree turn out of it, so on and so forth. Oops, 180 degrees, right? So, and then if I wanted to actually drag and pull, I have different shape handles now out of that object, and Revit remembers those embedded things you were doing. So in this case I can pull it up or pull it down. So let's go ahead into the editing environment for these conceptual masses. Tab over, I'm going to delete, excuse me, tab over, select the whole object, delete it off. Right, my work plane, since it's still shown here, is still on that. I'm going to go ahead and reset my work plane down to the level 1. In this case, we're going to start with just a simple box, and we're going to pull the box apart. So I'll go ahead and create form with my box, and immediately you'll see that I have this kind of coordinate plane system. And most people that have done modeling before will know, you know, this is going to be your X direction, Y direction, and a Z direction. So if I highlight and grab the arrow for the Z, it'll actually drag in the Z. If I highlight in the Y direction, it'll constrain me to the Y direction. If I highlight the X, it'll constrain to the X direction. Right, and then I have this ability to work in an actual planar direction by selecting the arrow in between the arrows, I'll call it. A couple other things I can do, let's get back to the original box, is I can highlight, and you'll notice that things are getting highlighted, and I can cycle selections through the tab key. I can select the whole object. I can select just an edge of that object. If Revit's nice to me today. I can select, in this case, just the vertex of that object and drag it out. I can select just the edge of this object and drag it out. Right, so I have ability to do as much as I want with this piece. So imagine it's like a piece of block clay that you buy from the store, and now I'm just sculpting in the computer, basically. I'll try and get that bottom edge here so we can flare it. Okay, so a couple other things I can do with it. It's like, okay, that's great, but I don't have access to, you know, what if I want to do something with the middle of it? So I have this ability to add edges, which are going to go vertical with the object. So I'll put a couple of verticals in there, and then I can also come in And if I select my object again, I can do horizontals by doing the profiles. So profiles allow me to add pieces in there. Now you'll notice that they're disappearing. The only way to get back at those, now if I select it I can see it, but I can't edit them. So I have this ability to then X-ray view, right? And then I've basically made this three-dimensional matrix out of my box that I can now say, you know, if I want to just edit, let's pull off of that so you can see the whole thing. I can actually edit individual segments now of this particular piece of geometry. And then you get this warning, highlighted geometry no longer determines a plane. You know, that's okay. Sometimes Revit gives you warnings that you just need to be aware of. And you can just ignore them. Right, so in this particular case, now I'm pulling apart control points within this geometry, and it, you know, in some ways it's really simple. In some ways it makes you wonder why some other geometry programs haven't done this. Rhino in particular does have this ability to do cage editing and things like that. Right, I'm going to ignore all that, and I'm going to drag up my top piece so it looks more like a tower per se. Alright, so I'm making more and more of a shape that I'm working with, and cancel out of that error. So basically what that error is saying is that unable to create form element, self-intersecting geometry or singular geometry would occur. So basically what it's saying is that it's not going to make something that intertwines on itself. So if it goes in and out on itself, it's gonna say no. And you'll notice if you try and do any type of mathematical curves, Mobiuses and things like that in Revit, I found that are very difficult to have happen, if not impossible. Tab over. I'm just going to go ahead and drag this particular set out. You know what, that's good enough for now. A couple other things, you'll notice that there's these black dots, right? So the black dots correspond with where that profile is happening. So if I want to get back to the original set of profiles, right, I can come in here and I can say, if I tab over to it, I can say I'm going to turn off my X-ray, right, and I have my smooth geometry now showing. Or I can come in and select my tab to get to something else. I can also create form off of individual pieces of geometry, so the things I've now pulled away from the object, I can select and make new form elements off of them, so I can create forms off of singular surfaces. Right? If I select this whole entire piece of geometry, instead of doing that, I'm going to use the filter. I'm going to select just my form. Right? I can use the dissolve command. Oh, actually, since we created the other forms, the dissolve command won't work on this. So I will select just the original, and then I have access to this dissolve command. So what the dissolve command does is it gets me back down to those original profiles. So if I needed to re-sweep a new piece, right? Let's say I was unhappy with that piece, or some of the stuff got a little funny, or I just wanted part 1 and part 3 up here, I can create a form in between those, right? So it allows me to then go back in a few stages and get back to what I wanted or what I didn't have before. A couple other things is now that's all solid modeling, and I hinted at it a little bit before in the tutorial, is the fact that I can come in here now, tab and delete that, and tab and delete that, drag over here. I'm going to filter that out. I'm going to delete off everything but my lines, reference planes. Get rid of the lines and reference points. If I wanted to make surface data in Revit, so I wanted to actually just do a surface, what I can do is I can select this line tool, right, and I have this make surface from closed loops, and then I can use 3D snapping as well. So let's say I wanted something that was a little kind of curvier. I can do and a little bit more loosely defined, right? Revit's going to allow me then to immediately place in based on those points, right? So I can go, the sky's the limit with this particular set. If I wanted to then draw something that was more turned on its side, what I can do is I'll set that work plane, come back in, make sure that everything's checked, right? And I can do anything I want with the planar tools, right? And then I have my surface, and then I could say create form off of that surface, right? So I have the ability to predetermine what I want it to do ahead of time. And when you have this particular capability, I think then you have you can actually do some kind of better things with it. So if I needed to, have this particular top on this building, and all I had was point data to come off of, and I couldn't get the extrusion to come out at the top of it, I would just come in and create form and be able to drag that down. And I would put a void piece, and then I would have my tower that has a slightly curved angle at the top. Okay. So I'll go ahead and delete those off, and we'll get into loading into the project file. So what we went over is we were able to make massing environments that were precise geometry in the generic models. We've now made sculptural pieces and really loosely defined masses into the massing files. In both of those cases, the generic models won't have the ability to make mass floors unless you load them into a mass family first. Mass families can be loaded into the project file then and be able to calculate data, mass floors, areas, things like that. In the project we can make these things, but we won't be able to share them from project to project. What's nice about making them as a family is if I make this generic building block, which we'll do in the third tutorial, I'll be able to share that between project files. So we'll get into making actual masses in the projects here next. So in order to make a mass in the project file, what I'm going to do is I need to completely say no more massing environment. I'll go into File, New. I'm not going to save the project for this. I'm going to come in, and if I wanted to make a mass inside the actual project file itself, you'll notice because I see the elevation tags, I'm actually in the project. I can go to Component, Model in Place, and you'll see all those family templates that we originally wanted to load and model geometry in are preloaded into the project files themselves. So anything to do with windows, walls, topography, be it ceilings, columns, those template files are essentially already loaded and loaded with the subcategories that we'll learn how to use later in the class. So in this case, I'm just going to do a mass, and I'll click OK. I'll call it tutorial. And I'll say OK. Now I can also within this mass family load more components, but we're not going to get into that. I'm just going to go ahead and show you that the same thing that we did in the conceptual mass environment is set up the same way. So there's only one button functionality when we do that for the mass environment itself, right? And excuse me, that piece, because we did not actually select that, I need to actually create form off of that, and then I'll finish my mass. Now if I wanted to have access to the actual tools, right, I can model in place, and in that case I would do something like a generic model. So if I did a generic model in place, right, I have access to those tools again, and I can do my extrusion, and then I can actually do more complicated, complex things that are more precise for the project, right, all of which do the same exact thing. And I'll finish that model, right. And in VV we'll say I need to show masses in case you lose what your masses were, right. It's handled through visibility graphics. So there we have both extrusions, both made from a mass and made from a generic model. What makes the difference within that is that if I do this idea of mass floors, I check 1, check 2, and click OK, and I select on this guy again, I cannot make mass floors with a generic model, which is kind of what I said before. In this particular sense I can, and what that mass floor is for people that really don't know what it is at this point. I go to the default floor view, and again I can't see my mass here, so I do VB for visibility graphics, make sure my mass is checked. I click apply. You'll see that I have my original mass here, and this is actually a mass floor. So if I hover over it, you'll see it's called a mass floor. And what we'll do in the next tutorial set is we'll actually build a building block that has parameters assigned to it with heights and widths and material parameters And we'll make several types out of that specific one piece of geometry, and then we'll pull mass floors. And then we'll learn how to actually pull floor data in terms of like area and things like that off of that floor data.